Hi, today we're going to be working on adding and subtracting rational expressions, mostly by going through a couple examples together. Let's start with just reviewing how we add fractions, especially when we have a common denominator. When we have a common denominator, it actually becomes pretty simple. We want to combine what's on top. So in this case, we have 2 over 5 plus 3 over 5, same denominator, so we add the 2 plus 3 on top. You keep that bottom part the same, so it stays 5. We add. 2 and 3 is 5. We have 5 over 5. And then the last step is just to simplify if possible. And in this case, 5 divided by 5 is 1. Anytime everything cancels, it's equal to 1. So let's take a look at an example that has variables in it. In this case, the variable x. So in this case, I look at these two fractions, I look at these two rational expressions, and I still see the same denominator, x plus 2 and x plus 2. That means we can go ahead and immediately start to try to combine. What we want to be careful of, though, in particular, is when we have subtraction problems. Because when we are subtracting, we need to make sure that we are subtracting everything on the top from that second fraction. That means, in this case, we're subtracting that 8x, and we're subtracting the 10. And then we want to combine. Now, what we don't want to forget is that even after we've done all the subtraction, we may still need to simplify. To simplify, remember, we're just going to factor and cancel. So, because this is an online video, you can pause right now, and you can actually go ahead and try to figure this out. Go ahead and factor. But I'm going to just keep talking. So the top factors is x plus 2, x minus 5. We see that we have the same term, the same expression, x plus 2 on the top, x plus 2 on the bottom. We can cancel those out, and we're just left with x minus 5. And that's our answer. With this one, we're looking at 3 over 5x plus 1 and 10 over 1 plus 5x. Are the denominators the same? Again, pause these videos as you need so you can work through these problems on your own. But yeah, they are the same. 1 plus 5x is the same thing as 5x plus 1. They're just written in a different order. And usually it is a good idea to try to rewrite things in that standard form with the x's first and the constants second anyway. So they do have the same denominator. Combine like before. Add the tops. 3 and 10 is 13. And we should check to simplify, but in this case we really can't break down the top or the bottom in any meaningful way. So we're just done. So here's another one. 2x plus 1 over x squared minus 4 plus x minus 1 over 4 minus x squared. So are these denominators going to be the same? Well, they look the same. Well, they look similar, but they're not actually the same. They're close. If we take that second denominator, the 4 minus x squared, again, let's rewrite that in our standard form with the x's first. Just be careful, though, the signs are attached to whichever term is in front, so it's really a minus x squared plus 4. Now, because it starts with a minus, we always want to factor that negative out if possible. And when we factor that negative out, we're left with the quantity x squared minus 4. So I brought that back over, and we see, again, they look really similar except for that minus sign. Now, the beauty of this one is whenever we have a fraction and it has just one minus sign, we can move it to the top, the bottom, or in front, and the fraction stays exactly the same. So, a simple example, if I have negative 3 over 7, or 3 over negative 7, or a negative and then 3 over 7, those are all going to be the same fraction. So I'm going to utilize that same trick in this problem, and I'm going to move that minus sign from the bottom to in front. And now it becomes a subtraction problem. So now I have a common denominator, and all I do is change it from an addition problem to a subtraction problem. Now we want to subtract. So now we need to combine on top. We want to be really, really careful with subtraction problems again. So on the top, I'm going to subtract that x, and I'm also going to subtract the negative 1. But when I do minus minus 1, well, the minus minus becomes a plus. So the top, I have the 2x plus 1 minus x plus 1. Again, combine. 2x minus x is x. 1 plus 1 is 2. So I have x plus 2 over x squared minus 4. And again, we're trying to simplify. Factor if we can. That denominator is going to be factorable. It is a difference of squares, so we can use our little conjugates trick. So the denominator factors is x plus 2, x minus 2. Again, we look, do we have anything that we can cancel? And again, we have a factor of x plus 2 that we can cancel here. So I cross those off. Now I want to be really careful writing my answer. That x minus 2 is on the bottom, which means my answer, it has still got to be on the bottom. Now everything canceled on the top, which means if everything cancels, it equals 1. Just like from the first example, 5 over 5 is 1. And that's as far as we can go. And that's the answer to this one. Now let's look at this one, 3 over x squared plus 5 over x. These denominators are not the same, so we need to make them the same. Now there's a tempting common mistake to do here. We see that one has got a square and one doesn't. And so for some people, the intuition is to, well, just square everything on that second fraction. But we can't do that. We can only make these denominators the same with multiplication. So we ask ourselves the question, how can I turn that 5 over x, how can I turn that denominator of x into an x squared? What can I multiply by? Well, x. X times x is how I get x squared. And then we just have to make sure we always do the same thing to the top and to the bottom of our fraction. Because essentially what we're doing is we're reversing the simplifying process and multiplying by, well, 1, which doesn't change anything. And so on the top, we just have 5 times x, which is really 5x. We bring that back to our original problem. So 3 over x squared plus 5x over x squared. We're going to combine what's on top, 3 plus 5x. But there's really no simplification we can do there. One's a number and one's got the x's. So they're going to stay separate. They stay over that x squared. And honestly, it's fine if you just leave it as 3 plus 5x. But the more standard way to do it is, again, that descending order, right? Put the x's first and any numbers second. Now let's talk about how do we add and subtract when our denominators are very different from each other. And so what we're going to do is we're going to find this LCD by factoring. Factoring is a super important skill and technique to use whenever we're doing math. Trying to break these things down into their smaller components. Figure out what they're actually made of, and then it should make the rest of the problem much, much easier. So I want to factor each of these denominators. Now 6, how can I break down 6? 3 times 2. How can I break down 10? 2 times 5. And so I've color-coded these because I think it'll make finding the LCD a little bit more clear, because our LCD has got to contain both of our denominators. So our LCD has got to contain a 3 and a 2 for 6, and it's got to contain a 2 and a 5 for 10. However, that 2 is shared by both of them, so I really don't need to include it twice. So I need the 3 and the 2, that'll get me back to 6. I need the 2 and the 5, that'll get me back to 10. And so I don't want to add any extra factors into my LCD. The LCD, standing for least common denominator, we do want to keep it as small as possible. And we have 3 times 2 times 5, which gives us 30. Now we ask the question, how do I make each of those original fractions so that their denominators are 30? Well, when I start with 7 over 6, 6 times what gives me 30? Well, 6 times 5, and I do that to the top and the bottom. So that gives me 35 over 30. With the second fraction, 3 over 10, what do I multiply 10 by to get to 30? 3. And we can kind of see, too, that when I have it underlined, what's missing in each case becomes a little bit more obvious. So I know exactly what to multiply by. Now, I take my two equivalent fractions, bring them back. Right? The 7 over 6 becomes 35 over 30. 3 over 10 becomes 9 over 30. Add the tops together. 35 and 9 is 44. 44 over 30, well, we'll reduce that. Right? Find any common factor. In this case, it reduces to 22 over 15, and that's what we want to record as our final answer. We're going to use that same exact strategy now when there's variables. We want to break down the denominators and figure out what they're made of. So the first one, 3y, well, that's just 3 times y. And y squared, that's y times y. So when I build my LCD, I'm going to need a 3, a y, and a y and a y. Now again, they're going to share a common factor. So when I build my LCD, that 3y and the y squared can share that y. Again, I want to make it as small as possible. And as long as I can see each of my original denominators in my LCD, I'm good. So my new LCD is 3y squared. And I have to ask myself, how can I make the others look like that by multiplication? Well, my first fraction, 5 over 3y, I'm going to need to multiply by y on the top and bottom. And the denominator that is y squared, all that's missing is the 3, so multiply the top and bottom by 3. And my two new fractions become 5y over 3y squared and 21 over 3y squared. For this one, I want to subtract, but again, when I try to combine the tops, 5y and minus 21, one's got a variable, one's just a number. There's nothing much I can do there besides just write it as 5y minus 21. Again, we want to check to see if we can factor anything, but there's no meaningful factorizations, so there's nothing to cancel, and we're done. That's our solution. Now let's take a look at about the toughest problem that we're going to see in this whole unit. All right. Again, this might look like a beast, but we're going to break it down the same way. We're going to find our LCD by factoring. We're going to build our LCD with those factors that we found, and hopefully this will go pretty well. So we'll start with the x squared minus 9. Again, pause the video, find the factorization yourself, and then check it. But x squared minus 9 factors as x minus 3, x plus 3. And then I need to factor the x squared plus 8x plus 15. Again, pause, take the time to factor it, and check to see if you got the same answer in B, which is it factors as x plus 3, x plus 5. Again, I want to build my LCD, so my LCD needs x minus 3, x plus 3, and it also needs x plus 3, x plus 5. Just like the last two examples, we have a shared common factor of x plus 3, so I only need to write it once. And again, hopefully we can see that we have our first denominator and our second denominator included in my LCD. Now, in particular, with these problems that are a little bit more complicated and a little bit longer, never, never, never multiply it out. Leave your LCD in the factored form because, again, we want to simplify at the end, and we might as well just leave it factored. So there's my LCD. Now comes the step of finding the equivalent fractions. So with that first fraction, the 1 over x squared minus 9, we know how that factors, the x minus 3, x plus 3. So what's missing? X plus 5. So we need to multiply the top of that fraction by x plus 5. We need to make sure we distribute, but 1 times x plus 5 is just x plus 5. So we have x plus 5 over that whole big LCD. With the second fraction, that factor denominator already has the x plus 3, x plus 5. So what's missing is x minus 3. Be really, really careful with these problems. After we do all of this work, the most common mistake that I see is that we forget to distribute on this step. That means I need to multiply 2 times x and 2 times minus 3 so that the top of that second fraction becomes 2x minus 6. So now we have both of our fractions with that same common denominator, and we can go ahead and combine. Now again, this is addition, so fairly straightforward. X plus 2x is 3x. 5 minus 6 is negative 1, so the top becomes 3x minus 1. There's no other factorizations I can do there, and so this problem is done. So to kind of recap, we always want to make sure that our fractions or our rational expressions have the same denominator. If they don't, we're going to find that LCD by factoring, and then we have to work to find our equivalent fractions. Once we have that LCD, we combine the tops or the numerators, we keep the bottoms or the denominators the same, and we always check to see at the end if we can simplify by factoring and canceling. That wraps it up for this lesson. Good luck with your homework.